So today we are going to talk about unleashing the power of GitHub Actions for platform engineering with Mick McGrath, Director of DevOps at Bitovi. Mick will introduce himself a little bit later, but before we get started, I just wanted to let you guys know that you can find us all across these different channels, right? So we have platform engineering community. You can go in and join our platform engineering Slack. If you missed a talk or you want to dig deeper into some specific topic, also you can go into our platform engineering YouTube and see all of the recordings over there. And if you didn't know, we have Platform Weekly, which is our delivered hot and crunchy newsletter. We deliver it every week, and it has all of the recent news in platform engineering. Also, for the next weeks, what webinars we have next week, we have Unlocking the Secrets, Navigating the State of Secret Management in 2023 next week. Then another one is Platform Engineering meets Service Mesh, SRE Love Story, and Database Guardrails, New Era for Developers and Databases on September 14. You can go, as I mentioned, platformengineering.org, sign up for the next webinars that are coming up. But that's about it from my side. This webinar will be recorded, and we'll send over the slides and webinar replay to everyone who registered. So throughout the session, please think through questions. You can ask questions in the Q&A section, and we will cover those with Mick after the content presentation ends. And that's it from my side. Mick, over to you. Let's see from where people are joining us from while you're trying to share your screen, right? We have Dublin, we have France, we have Texas, Sofia, London, a lot of London. Very late for you guys, sorry. I get that sometimes our like webinar scheduling, right? Like we have 9 p.m. Central European time, also 7 p.m. Central European time. Oh, and there is one from Mexico, very cool. Very nice to see you. Cool. Well,
awesome.
Yeah, Mick, over to you. I see full screen, so everything's good on your side.
All right, cool. Yeah, great to be here. My name is Mick McGrath, Director of DevOps at Bitovi. We provide application development and delivery services for our clients. We also release open source software that we develop with and for our clients. And today I'm going to be talking about GitHub as a platform engineering platform, allowing any developer to deploy any project to any cloud provider with GitHub. Let's get into it first. Here, because we're going to get into some architecture, so hold on to your hats. I'll try to not get too complex with this, though. All right, so the rough agenda, we'll do a demo. We'll talk about why, what, do a bit of a maturity progression, look at the goal of platform engineering, what it can do, and then how it integrates with GitHub Actions. Go through some examples and repo structures. I'll do a call to arms because everything's better together. We'll check in on the demo and then we'll pause for questions. So it's a lot to cover. Let's get into it. First of all, let's start the demo because everybody loves a good demo, and I hopefully made all the appropriate sacrifices to the demo gods before we started. So what I'm doing, I've got a repo over here. I'm going to create a pull request, and all I'm really doing is changing some code. This is a Node.js app. It has a Docker file, it has a Docker Compose file, and it has some workflows defined that are going to pull in an action, which I will elaborate on here shortly. Right now, all I'm going to do is create the pull request, and what this is going to do is kick off an action. All I'm going to do is check over here on the action to see if it kicks off. Give it a second. It usually does take a second. There we go. Adjusted the commit for the webinar. And I'll check over here at the instances. You'll notice I've got it scoped here. I did some prep before this. Scoped to platform engineering. There's a lot of naming and tags that you can use to search resources, but this is a virtual machine list in AWS. So right now we just have main, another one will pop up later. So that's the demo. That is running, usually takes about 5 minutes or so. And essentially that's creating a pull request environment for my change. So I can check my change in a live environment before I merge it in with GitHub Actions only. All right, let's head back over to the demo, or to the presentation, I mean. All right, so I just made a code change, kicked off the demo. So now let's talk about why platform engineering. Well, for starters, there we go. Gartner cares about it a bit. They put it on their hype cycle for emerging technology in 2022. So it's been growing for a bit. Also, Puppet in 2021, the State of DevOps report said platform teams are key to success at scale, and they're focused on this, or they're seeing this so much that in 2023 they dedicated the entire State of DevOps report to platform engineering. Others are talking about it too. Humanitech, Pulumi, Harness, everybody's got a lot of blog posts and articles and guides about platform engineering. So it's a thing. What is it though? Platform engineering, platformengineering.org says platform engineering is the discipline of designing and building tool chains and workflows that enable self-service capabilities for software engineering organizations. I'm not going to read the rest of it. What I want to focus on is tool chains and workflows that enable self-service capabilities for software engineering organizations. So it's like building the tools that allow developers to move forward. To give another feel for it, I want to go through a bit of a DevOps maturity progression. So say when you start out, if you're a developer, you start out with a project, you don't really know DevOps, you hop into AWS, you click around, some cloud provider, click around, start up a VM, figure out how to connect to it, figure out how to get your code to it. A lot of this stuff needs to be figured out. So there's a lot of overhead. Eventually you figure out, okay, well, we need some DevOps team members. So we have people who are now focused on this area of complexity. And now our developers can focus on what they want to do and ask the developers or ask the operations team for infrastructure. So this is the merger of dev and ops, where everybody's collaborating together to sort of make this this utopian community of working together. Trouble is, it turns out specialization is useful, I think, and not everybody on the developer side, for example, wants to learn Terraform. Okay, so there's use for specialization, but there are folks who do, like folks on the developer side, who believe in this community, and so you're sort of branching out and getting more skills. And similarly, people on the operations side are, there are people of interest, people who are interested in getting into, more rigorous, development practice, software development practices. Okay, so I think it's sort of actually a natural progression. So eventually your DevOps team is going to refine themselves to the point where they have all these tools sort of built and they're making it easier for themselves and developers. Okay, so I think we all get what platform engineering is. Enough of that. The goal of platform engineering, in my view, is two things. It's user experience on two levels: end users and developers. So for end users, these are your customers. These are the people who use your product. Their user experience is what I'm referring to here. They come to you because they love your product, they love your company. They stay with you because they're heard, right? If they have issues with the software, they find a bug or they want new features, those things get rolled out to them. Bugs get fixed quickly, features get rolled out swiftly. So the end users' happiness matters. How do we give the end users their happiness? How do we give them those features? And that's through what the developers can provide. So if we give the developers a really good experience, they're going to be able to provide happiness to end users through automations and abstractions and things like that. So that's how we make the users feel like they're heard. How do we make the developers' experience, DevX stuff, better? We make it as easy as possible for them to sort of own their own destiny. Developers have a lot of things to deploy and a lot of places to deploy them. And so I want to go through some deployment scenarios. And I think we're also going to have a poll on where you deploy stuff. So this is like compute instances, and I'll kind of elaborate while that poll is going out. The general pattern is deploy X to Y. So get thing X to place Y. So really that means get a deployable artifact to some compute somewhere. right? That compute could be serverless, it could be Kubernetes, it could be a virtual machine, it could be a CDN, those kinds of things. So that's the general pattern that we're looking at in terms of these deployment scenarios. And there we go. So we've got deployment artifacts, deployable artifacts on the left, and compute on the right. All right, so for the front end scenario, you have some front end application at build, it's got like maybe a static build, and you have this deployable static artifact that you could put somewhere. GitHub Pages is a really good place to start. You can get just a quick site up and running really quickly. GitHub Pages would be the compute in this scenario. It has a lot of compute under the hood, but they abstract a lot of that for you. Anyway, you have a front end app, you can get it to GitHub Pages. You might have a back end. Choose your programming language. Anything will do, and you want to host that publicly on a virtual machine, or you want to run some workloads. You might want to put that into a virtual machine on AWS. But why stop at AWS? You could put it in Google Cloud. You could put it in Azure. Let's say your front end app gets to the point where, okay, you need more environments, say, because GitHub Pages only gives you one thing to deploy. So it's pretty good for docs, maybe like public docs, but it's a little bit harder for multi-environment. So if you have a static app and you want multi-environments, you can put it in a cloud provider with the AWS CDN. You put CloudFront in front of an S3 bucket, and there you go. Your backend might need to scale more. Maybe virtual machines aren't really cutting it. You need better scalability and flexibility. You have more services to work with, so you can put that on Kubernetes, potentially. You can do a similar thing with serverless for Lambdas. This slide isn't filled out, apologies for that. But you could put it on, you could do serverless with any flavor. So anyway, and one more thing here, I guess, for large language models or machine learning models hosted on something like Hugging Face, can deploy that to SageMaker, right? So there's lots of different things that could be deployed. So I want to come back to the pattern, deployable artifacts to compute. But what I want to focus on is this in the middle. How do we get the deployable artifact to compute? And the answer is GitHub Actions, using infrastructure as code within GitHub Actions to enable deployments. So here I'll call out another poll. I guess the other side of the poll is there already. So what compute are you using? And are you using GitHub Actions? So let's see what these deployment scenario. Oh, actually, let me get into just a brief overview of GitHub Actions. I'm not going to go into depth, but for the sake of anybody who joined that isn't aware, GitHub Actions allows you, it provides compute to run steps on triggers to a repo. Those triggers could be a new commit to a branch. It could be a new version was created. It could be a pull request was created or closed. Those triggers can kick off steps. And in those steps, we can perform deployments. And that's GitHub Actions for platform engineering, is that we're able to even use GitHub Actions abstractions, which is fun to say, which are composite actions that allow you to abstract some things and provide inputs. And so we can have a composite action that's a translation layer between inputs for developers to give them a good like interface to work with, and the infrastructure as code, which is all the complexity under the hood. All right, so let's revisit our earlier examples of with this in mind, that we have these GitHub Actions in the middle. So we have a front-end app to GitHub Pages. The GitHub action to enable this to happen looks about like this. Okay, we give it a name. We set our trigger on pushes to main. We have a set of jobs. The only one in there is deploy, which uses a React to GitHub Pages action and gives it a path for where the distributable, the built artifact is going to live, or the built files are going to live. Okay, that's pretty simple. I like it. Let's revisit the back end to the AWS VM one. What does that look like to enable deployments to any programming language, to AWS and host it live? It looks like this. Okay, it looks very similar, pushes to main. The only thing that's added here is the cloud provider credentials and the app configuration, right? So that app configuration can be abstracted and provided by the operations folks. So you can also forego having the cloud provider credentials here if you have custom runners, which is a deeper level conversation. GitHub Actions we'll talk about probably another time. But you can get rid of that depending on how it's set up. But you can also leverage GitHub secrets to provide access to developers. Okay, Google Cloud Platform, same thing, right? Provide the cloud credentials and app configuration. Azure, same deal. Front-end app to AWS CDN, similar footprint, cloud credentials and app-related config. Back into Kubernetes, this one's actually in progress for us, but you can deploy an entire cluster with all the bells and whistles, like your entire observability layer, Prometheus and Grafana and Jaeger and all of that fun, Loki, all the things you need, just out of the box for developers so that they can sort of run their own clusters if they need, or deploy to existing clusters. But it's the same configuration. You can have all of that with just this small bit of configuration here. This doesn't exist today, but it very well could. You provide your cloud provider credentials, your Hugging Face token, and you can launch with GitHub Actions, with a simple repo, your own model from Hugging Face, like, I don't know, Falcon or Llama 2, for example. Okay, cool. So let's take a look again at this back into AWS VM. Let me just double check on my time here. I think I'm doing okay. All right. We can even make it really easy for developers to enable a database. So back into AWS, we have our app, it's Dockerized, we're putting that onto a virtual machine, but we want RDS access, right, with all the backups and everything. We can do that pretty easily with this interface. So the developers, all they say is, I want a Postgres database. And here you go, we can provide into the running virtual machine access to the database for the developers. All right, so how does it work? So I'm going to go through, oops, let me get this out of the way. There we go. I'm going to go through a few repo scenarios for these different things and sort of tie together what this would look like. Because this is really the key, I think, to platform engineering with GitHub is the repo structure and how you tie them together and what their roles and responsibilities are. All right, so we'll start with a box. I'm going to call this our box of complexity for now. At the very beginning, we have a frozen computer. Let's try it again. There we go. At the very beginning, we have a deployment repo. It's our application repo. In there, we have source that a developer will contribute to. This is your app. In there, we might have some other things like secrets, which the operator, in this case, operator is sort of a loose term in this context for like an SRE, operations, automations engineer, those, network admin, those types of folks. This is somebody who's going to manage sort of that, the surrounding infrastructure. So they might come in and drop some secrets, but right now I want to focus more on what the developer sees. So this is a repo for the developer in a scenario that has this platform engineering paradigm set up. So they're going to have a workflow to deploy to dev. They're going to have one for QA, one for prod. Really, these are all just GitHub Actions workflows. This is well documented. Those are sort of the steps that I showed, and you'll see more of here in a minute. Okay, then the other layer, another layer we have is the action repo. This is where we put the infrastructure as code and to which the operator contributes. Okay, then in the middle, we hook those up. Let's see, there we go. In the middle, we hook those up so that each environment pulls an instance of this repo and deploys its infrastructure as code according to the environment that's deploying it. So we'll deploy dev, we'll deploy a bunch of Terraform, and we'll feed in inputs that say this is dev. So that'll be tags, that'll be URLs, all those kinds of things. You get your own sort of instance for each of those environments. Okay, so in the infrastructure as code is like anything really that you want. Terraform, Helm, Ansible, Pulumi, custom CLI tool. We've got something we built that's part of another tool that turns any CLI tool into a YAML that you can commit and do infrastructure as code. So really anything can go in the action repo. You're just abstracting whatever happens in there to the developers with the set of inputs. You're sort of doing the mapping of inputs to infrastructure as code. All right, so let's back up a little bit and get these things to load. We can, like I said, we can enable databases so that each of these environments can get their own database. All right, so let's say now we've got our app, it's running, it's hosted on our virtual machine, and we want to add docs. Okay, docs are really good to put in GitHub pages. So we have a docs directory there. We pull in another GitHub action that takes our docs to GitHub pages. So now we're deploying our app to one place and our docs to another. We could put the UI in there, right? We could have the UI and pull in an action. This is deploy the UI. And that's maybe going to a static site to AWS, right? But this is getting a little bit, this is like the mono repo approach. I feel it's getting a little bit crowded, makes it difficult in terms of modularity, I think, from a platform engineering perspective. And we could even add like Helm in here, because each application might want to be deployed to Kubernetes, so we can provide Kubernetes deployment configuration. But again, that's getting a little bit out of whack. So let's break it up a little bit, and we can put the UI. So you see the UI over here on the left is now in its own repo. So now we have the app repo, the UI repo, and then we're pulling in several GitHub actions over there from the actions layer, right? So we've got a lot of environment deployment configuration in the GitHub workflows. So each one of these has dev, QA, and prod, but they can now each have their own docs, and they're all nicely separated, can be separately versioned and all that. Okay. Let's simplify things down a little bit. This is a simple deployment. We'll simplify it even further and say over on the left, we have service A. It's got some deployment environments, and it's using a specific environment to do those deployments. Okay, what if we have another service? This makes it really easy. We have another service, does the same thing. They each get their own virtual machines and that kind of thing. It works really well for PR environments as well. But let's say we want to go, okay, let me go back here. Let's say we want to go, instead of deploying to a virtual machine, we want to deploy our service to Kubernetes. Okay, so now we're getting to the point where our different environments might have shared infrastructure with other services, right? Dev cluster, QA cluster, and prod cluster. So where are the clusters? How do we create those? In this paradigm, we can have a repo. That's our infrastructure creation repo. We can have a GitHub action workflow in there that pulls in an action that is deploy Kubernetes. Again, they can have all the bells and whistles that you need, observability, ingress, all that fun stuff. We can have one of those per cluster, and now each service has an endpoint to point at and deploy to a cluster, right? So now the infrastructure deployments and the app deployments to those can all work really well together. All right, so there's this infrastructure repo that will create, it's going to call in the action and create the clusters. It could also create other shared resources. So I'm going to go really quickly through this because it's going to be in the recording, but I don't want to spend a lot of time on it because it's probably more complex. Because I've got our box of complexity here and it didn't fit all the way. So I want to skim through it. But essentially, there's another layer. So what if you have virtual machines also that want to have like the same VPC as some of this other stuff, and so they need common infrastructure as code. And so there's another layer to these GitHub actions, which we're calling commons, that has like common infrastructure as code that we use in other sets of action repos for things. So this would be like, Postgres, RDS creation. That Terraform, ideally, we don't have to create it for this one and this one and this one. We want to share those. So anyway, that's commons. There's a deeper layer to this. It can get more complex, but I wanted to just sort of, you can see our box of complexity is stretched too much. All right, so coming back to these multi-repo deployments, let's simplify the action side a little bit. And I want to just more cleanly highlight the layers here of what I'm talking about. So these are like, roles, I guess. There's another term I'm looking for. So this is where you have separation of concerns. You have your app/deployment. It's got an environment awareness. This is where you define your environments. You define how to access your secrets for the environments or access or whatever it is that's environment specific. And then layer 2 is more like the generic stuff. These are like your libraries of ways to deploy things. Then you have this other layer, which is commons. You have another actual layer. Again, we're stretching the bounds of our complexity box here, but I do want to point this out because what this paradigm also allows you to do is you can have very specific actions that deploy specific things. Like StackStorm, for example, is an if this then that microservices-based architecture system that you can run it on Kubernetes, you can run on VM, but it's got a lot of different microservices. And we have one action that you can deploy StackStorm to AWS. You don't have to worry about all the underlying complexity. It'll create your VM, it'll put it on there. You can do the same for Kubernetes. It'll create the cluster and put it on there. So you can have these deploy your app. Another one we did was deploy the stable, stability. Oh man, I can't remember. It's the Stable Diffusion's open source UI, Stable Studio. We were able to just like take that, wrap it up in one of these and host it pretty quickly. So anyway, I wanted to point that out because it's really very specific use cases and have an action dedicated to that because it gives you a lot of maneuverability and consistency. Okay. So back down to the 2 layers, I want to completely simplify this. Really, if you're a developer in this paradigm, you can generally focus on your application. And then if or you're a UI UX developer or implementer, and then if you're an operator, you can focus on providing the infrastructure as code and mapping that and giving a good developer experience to your users, to your developers. And build out anything else that you need. So what will you deploy? This is the call to arms. So I'm going to go out on a limb here and say that we at Bitovi really believe in this technology. I think it's got a lot of potential that's not really untapped. And so the more we as the community, especially like platform engineering community, use GitHub for deployments, the more they'll listen to us and provide more and more helpful features to facilitate deployments. That's my belief. Let's go check back on the deployment real quick. And then we will go over to questions. So I'll come over here. This was the workflow run. If I pop in here and look at the output, this is a PR environment that, there we go. Yeah, there we go. Hello, platform engineering webinar. This is a PR environment. VM was spun up. How long did it take? It took about 4 minutes, a little over 4 minutes. You can also go to the root of the repo and check it out over here on deployments. We've got this 5/merge, right? This is PR5, and you've got the deployments associated with that PR right here. Again, there are a lot of really good features for GitHub Actions, using them for deployments already. And I can't wait to see how that's going to grow and get better. I'll just pop over here real quick and show the instances. And there we go. We've got this this instance here. If you were to look at the tags, you'd see a lot more relevance than that string there, right? So this is what we just did. And I think let me pop back over here and make sure that I'm not missing something. No, that is it. Let me hop over to the chat. Let's see, are there any questions in the chat?
Yeah, there is one. If I can read it out for you, if you'd like. I'd like to know if you have implemented EC2-based self-hosted runners auto-scaling. Would be happy to hear about how you're doing it.
I haven't done auto-scaling for them. And I think, I haven't done auto-scaling for them. And I'd love to dig in. So if you want to hit me up sometime after this, I'll be on the platform engineering Slack. I'd love to dig into that. I would, I mean, it depends on where you're deploying to, also which cloud provider and what sort of auto-scaling capabilities they provide. I think there's also capability to provide a GitHub Action runner as a container in a Kubernetes cluster. I think, don't quote me on that, but I haven't done it specifically. I've used the runners for a lot of different things, but never in an auto-scaling capacity. So I'd love to dig in.
What is the difference between GitHub Actions versus AWS code pipeline?
AWS code, so GitHub Actions is like, if you want to deploy something right now, you could go into GitHub Actions, create it, like fork a repo that you want to deploy, add a GitHub action in there, and your runners are there ready to set up. AWS Code Deploy has more of a two-stage approach where you have to first set up the pipeline. You've got like a two-stage like infrastructure implementation approach. Ultimately, once you get everything set up, it does pretty much the same thing. The UI is different, how it reports on the pipelines is different, and it's going to be in their UI. The access is a little bit different. So it's a different approach. I think most pipeline runners, that's what I'd call these. And also there's another question here about Jenkins and code pipeline, code commit. There's like Harness is fantastic for deployments. GitLab, like all of these, like Spinnaker is a really good one. So there's a lot of different tools that could be used. A lot of them are either paid or hard to set up, I think is maybe the bulk of it. There are a lot of free tiers. Harness is a fantastic place to go if you want to do CodeFresh. Yeah, and like Buddy.works, man, there's so many. And most of them are good. What I look for in a good pipeline runner is shareability in configuration. Like GitLab, for example, provide like I'll just stick back to GitHub real quick. The composite action approach. Can I like create a catalog of automations? And then the other thing that I really look for is, can you check in the pipeline configuration? Because it's always like, can I get my automation configuration test running, how like deployment configuration and stuff as close to the code as possible while maintaining versionability? And then one of the other big things that I really strive for is GitOps. I'm a big fan of GitOps. I want to do everything through commits. And some of these tools have trade-offs with data versus commit-based approach. Where, you know, but again, Harness is really good, and they have both. You've got like two-way, and I think Spinnaker does okay sometimes too. But anyway, those are like sort of the core that I look for. There's a lot of differences in there. At what point would I move to heavier weight, like something like, you know, Jenkins, CI/CD tools, or code pipeline? Or I wouldn't call those things that I would move for. The things that I would move for is whenever your developers need more granular visibility into the deployments over time, which right now GitHub doesn't do a good job of showing from a deployment perspective. There was a tool that did it really well for CI, and I was hoping they would do it for CD. It's not going to happen, unfortunately. But maybe GitHub will do it. You know, again, the more we use these for deployments in GitHub, maybe they'll give us these features more.
Cool. Mick, we have lots of questions, so get ready.
Yeah, yeah, that's great.
Can you please talk about what goes into action repo?
What goes into an action repo? I can actually talk about that. I'm going to pick a simple one. I'll do GitHub React to GitHub Pages. This is a pretty simple one. So really the action, so this is the composite action that can be included in a workflow. And really you've got your inputs, you can specify outputs, and then it's basically a workflow, right? You have your steps that run, and in here you can pull in other workflows. And this composability is one reason it's really good. Another thing that I really like about the actions is that you during action execution time, you have access to the file system for both the app, the repo that ran it, and the repo that the action code is in. So you can put all your specific infrastructure as code in here. This doesn't have any. If I do Docker, the deploy Docker to EC2, you'll see in here, we've got just a bunch of infrastructure as code. In here, we've got Terraform and Ansible, right? So, and then there are scripts that run this Terraform and Ansible, and at the action layer, we just call those scripts in an order that we care about, provide inputs and outputs, and that's really it. So this action YAML file is a translation layer between these inputs and this underlying infrastructure as code. So in here, you can provide your variables in there, and you can translate the user inputs into these Terraform variables. So this is sort of a high-level view of what one of these might look like. Again, we've gotten to the point where we write infrastructure as code once, which is really, really cool. So, all right, good question. What's the next question?
I feel like you touched base a little bit on this one. At what point would you move to a heavier weight set of tools like Jenkins, CI/CD, code pipeline?
Yeah.
So
yeah, and I think the succinct answer there is developer experience. Whenever developer experience needs to be enhanced beyond the tools that you're currently providing, you need to you scale it up in some way.
Cool. And then the next question on this one, how about GitHub Actions versus Ado services? Both are from Microsoft and cloud-based, but Ado CVCS is a full ALM, application lifecycle management toolset with sprint and requirements tools.
Right. Yeah, I've seen Azure DevOps used more for project management than automation. I'm not sure why that is. And I think Azure DevOps, if I'm not mistaken, I think it's a superset of, or maybe a subset or a fork, I can't remember. It's somehow very, very similar. And I haven't honestly had a lot of interaction directly with Azure DevOps. But again, I always go back, like in this, I encounter this all the time. Just about every client we work with has a different way of deploying something, like a different tool. And so I always go back to the foundational features of a deployment. Can I check in my deployment configuration somewhere? Are my runners able to be up and running, pretty easily? Can I manage access? All those sort of foundational things. I'm pretty sure, Azure DevOps provides that.
Yeah, Daniel.
No,
I was just going to say that I'm switching to Q&A, just one after another. But did you finish, Mick? Sorry, I interrupted you.
No, that's good. Like I don't have a great answer for the difference between GitHub Actions and Azure DevOps. I'd be happy to dig into it and look into it with you. But I think they're related in some way. But I think they both are going to be pretty similar. I'm pretty sure you can do composite actions with Azure DevOps. Yeah.
Are there any benefits to using this approach over a tool like Flux?
So Flux, I think, is a pull-based. If I'm not mistaken, Flux is, and maybe correct me if I'm wrong, maybe just look it up. I think is like a pull-based thing where you deploy Flux into a cluster and it's going to keep your repos up to date with the things employed into that cluster. Argo, I think, is similar. Right. So the main question there is like, how do you get your cluster? Right. So if you have a GitHub action that's deploy my cluster, you could have a GitHub action that's deploy cluster with Argo on it or with Flux on it. Work together. And then you have Flux, which might be more useful in terms of features than you need than GitHub action for deployments and capability. We've seen, we work with young brands to sort of grow a lot of some of their and we started with one deployment paradigm and then migrated over to another deployment paradigm to migrate. So if you get started with GitHub Actions, mature enough of it to where it makes sense to bring on this external tool, and then you can migrate the parts that make sense. All right, the difference between an action and a workflow in a GitHub action. Succinctly, a workflow is a set of actions that are run in sequence. There's also a difference between there's also like an action you can think of as like this separate generic thing that takes inputs and outputs, and a workflow is what chains those together.
Cool. Let's go back to the Q&A section. How do you keep secrets away from everyone who have access to the repo?
So we leverage, a lot of different ways that you can do it. We leverage organization secrets in GitHub to provide access to infrastructure that we allow, like a sandbox account. And then we can provide more granular based on the repo. So we would have like a deployment repo that's like, this is the production environment. And so only people that have access to that repo are able to deploy things in that repo. So you can sort of restrict it that way. Again, you can also have like self-hosted runners and OIDC connections to connect GitHub more cleanly with your cloud providers to kind of lock down access that way as well.
So just to follow up, Raul is going to ping you on Slack. He says that your Kubernetes auto-scale is okay, but I'm interested in EC2 based. So he'll ping you on Slack.
Okay, cool. Cool.
Jefferson then asks, basically it works like a Terraform module. We have an action on the infra repo, for example, and then we kind of instantiate if from the application repo, but only passing parameters, all the code keep the infra code, correct?
Yeah.
Very short answer. You want to add anything?
Yeah, it's exactly what this sort of paradigm sort of highlights. It's been, there are lots of different ways. We've got some other tools I'd love to talk about under the hood for like how you orchestrate the infrastructure as code, make sure like how do you deploy Kubernetes and then things onto it in the same sort of pipeline thing that are fun to do. But essentially that's it. You have a composite action, this abstraction layer with inputs and outputs that has infrastructure as code, and you just, you document that for developers, right? And you're building a developer platform.
AWS code products are managed services. You don't run anything yourself. I guess that's just the comment.
Yeah, so this, I've highlighted a lot about AWS, but really, like, it's anything that that has an API you can deploy to, or with. So, all of like VMware and OpenStack and all of those types of things, most of them have Terraform, Nutanix, most of them have Terraform for them anyway. So, like, yeah.
Cool. How would you ensure you don't use unnecessary resources after a commit, for example, keeping a VM alive longer than required?
Yeah, this is fun. So this is where differences between GitLab and GitHub are highlighted really well. You can use timers. We're tinkering with having a separate have like some way of setting a timer, like a time to live. In Kubernetes, it's a little bit easier to do in Kubernetes and GitLab. But on the, so say I create a PR and we create a PR environment. At the very least, what we can do is when the PR is closed, you shut down that VM. And so that works pretty straightforward. But the tricky part is if I create a PR and forget about it for a week, ideally I'm not paying for all of that. So there's some way of setting a time to live. I can think of a few ways maybe to do it where you like have either an action that runs on a cron from time to time that, checks the config and shuts things down that have been on too long or something. That's probably the easiest way to do it. Otherwise, you can do some sort of event-based thing.
Do teams use the Bitovi modules in GitHub Actions generally instead of rewriting their own? If so, do they go through any security testing? Sometimes security teams get fussy. Yes,
we haven't gone through yet. We've got a client that's about to require it, and so we try to pay attention to that. We're not using a whole lot of like most of what our actions are doing under the hood is just composing other technology, and so it's definitely needs to go through a security review. We have teams that use them, and yeah, we work with clients that need a deeper security review, just haven't gone through it yet. So I mean, if you've got some security review you want to point at our actions, we'd love the feedback. And we will, we can also leverage a lot of GitHub security features as well. So I'll make a note definitely to turn that on and get all that stuff integrated. But most of it's
Mick, you froze for a second, but I feel like you finished the sentence. So.
Okay. Can you hear me now?
Yeah, I can hear you. Okay, last question. Can GitHub Actions be a standardized CI/CD setup for both private cloud and public cloud?
Yes. Well, so I assume I can speak to most of my questions here. So private cloud and public cloud. If we assume private cloud to mean like an internal data center that has some sort of compute management in there, then yeah, absolutely. There's nothing. You can easily you can provide your own runner, and then all of the code that runs in your runner is all inside of your VPC or in your actual network, so long as it can communicate back to GitHub to tell it the results and stuff. But there's a way to set that up. So, and then yeah, there's also GitHub Enterprise. You can utilize actions absolutely in GitHub Enterprise itself, whether it's on-prem or public enterprise. So I think yes to all probably is the answer there.
Cool. Well, let's give it 10 seconds. If anybody else has any last questions, we are happy to take. Yeah, and I see Samuel. Can you track workflow runs from repo 1 that is dependent on workflow run in repo 2, for example?
So this is, again, where GitLab, I think, shines a little bit better. They tie those together better. You can trigger cross-repo workflows. You can even wait for them to be done and report on the success. And then really the way to do it is, like, there's no out of the box. Last I tried to do repo to repo calls, it didn't work. It didn't show up in the UI to be able to track it. But what you can do is you can provide annotations in the summary, like you saw whenever I had the VM URL down there, is like success, VM created. You can put other things in there. You have full control over that section. It's all marked down. So you can put whatever you want in there. So you can put together like a chain of, things that triggered other things in there if you need to. Again, the more we use GitHub and the more that we ask GitHub for these things, like they're absolutely doing this whole user experience is key sort of thing. So they'll listen and hopefully provide us better connections between repo to repo stuff. Call to arms.
Cool. Well, thank you so much, Mick. For those who are asking the recording, yes, I see a lot of questions about the webinar replay. So guys, you can access it at our YouTube Platform Engineering channel. Please join Platform Engineering community. That's how you get updates on all the upcoming webinars, plus, well, definitely everyone who registered for this webinar and is on the webinar will get the webinar replay plus slides. We will send those over tomorrow. And yeah, feel free to ping Mick on Slack after the presentation. He is a part of the Slack already, just needs to write his introduction, right, Mick?
Yep, exactly. I'll do that right after this.
Cool. And thank you very much to everyone who joined. Let me just find the YouTube channel. Somebody is asking for our YouTube channel. It's just Platform Engineering. You type in YouTube and that's it. But let me get it here.
Yeah, while you're looking for that, I want to say thank you all for listening. I appreciate the look at what we're doing. I think it's important.
Amazing. Thank you so much. And see you guys next week. I already mentioned in the beginning, we have a bunch of another cool sessions coming up. So feel free to sign up to those, sign up to Platform Engineering Slack, YouTube channel, Platform Weekly. And if you would also like, you can become a speaker. Also, there is all the information on the website, platformengineering.org. Just submit the form and I'll be in touch. Thank you all and have a nice rest of the day. See you. Bye.